Very good morning, everyone. Today we'll see the grading requirement of aggregate. I am Dr. J. Sagaruban, Department of Civil Engineering, Rohini College of Engineering. A good aggregate should be strong, having sufficient impact, crushing, and abrasion strength. A good aggregate should be durable to resist atmospheric variation. It should be non-reactive type to avoid alkali aggregate reaction. It should be clean, is free from organic and inorganic impurities. Aggregate comprises about 55% volume of mortar and about 85% volume of the mass concrete. Mortar contain aggregate size of 4.75 mm and concrete contain aggregate up to maximum of 150 mm. Thus, it is not surprising the way the particle of aggregate fit together in the mix. As influenced by the gradation, shape and surface texture, has an important effect on the workability and finishing characteristic of the fresh concrete. Consequently, on the property of the hardened concrete, volume have been written on the effect of the aggregate grading on the property of the concrete, and may so-called ideal grading curves have been proposed. In spite of a extensive study, we still do not have a clear picture of the influence of different type of aggregate on the plastic property of the concrete. It has been this much understand that there is nothing like ideal aggregate grading, because satisfactory concrete can be made with various aggregate grading within the certain limits. It is well known that strength of the concrete is depend upon water cement ratio, provided the concrete is workable. This statement, the qualifying class providing the concrete is workable, assumes full importance. One of the most important factor of producing workable concrete is good grading of aggregate. Good grading implies that the sample of aggregate contain all standard fraction of aggregate in required proportion, such the sample contain minimum void. A sample of well graded aggregate containing minimum void will require minimum paste to fill up the voids in the aggregate. Minimum paste will means less quantity of cement, and less quantity of water will further mean increase economy, highest and lowest shrinkage, and greater durability. The advantage due to the good grading of concrete can be reviewed from the another angle. If the concrete is viewed as a two-phase material, phase and aggregate phase. It is a phase which is vulnerable to all of its concrete. Paste is weaker than the average aggregate in the normal concrete, with rare exception when very soft concrete are used. One of the practical method arriving the practical grading by trial and error method uh, to mix aggregate of different fraction in a different percentage and choose the one sample which gives maximum weight or minimum voids per unit volume. Out of all alternative sample, the fraction which are actually available in the field or which could be available in the field, including that the fine aggregate will be used in making a sample. One of the method that is called sieve analysis is used to finding the various fraction each and every um, sieves. The sieve analysis is conducted to determine the particle size distribution sample of the aggregate, which we can call gradation. A convenient system expressing the gradation of aggregate is one which the consecutive sieves opening constantly double, such as 10 mm, 20 mm, 40 mm, etc. Such a system employing a logarithmic scale line can be spaced to equal interval represent the successive sieve. Grading pattern of sample coarse aggregate or fine aggregate is assessed by sieving sample successively through all the sieves mounted over other in order to the size. With the largest size on the top, material retained on the either sieve by shaking or representing the fraction of aggregate coarser than the sieve question and find the sieve above. Sieving can be done either manually or machinally. In the manual operation, the sieve is taken given the movement in all possible direction. to give the chance to the particle passing through the sieve. Operation should be continued till such the time that almost no particle is passing through. Mechanical devices are actually designed to give the motion in all possible direction. So it is an important method to find the gradation of the given aggregate. Sometimes aggregate available at the site may not be specified or desirable grading. In such case, two or more aggregate from different sources may be combined to get the desired grading. Often mixing of available fine aggregate with the available coarse aggregate in appropriate percentage may produce a desirable grade. So this is all about grading of a aggregate.